Welcome. In this episode, we're going to explore a new concept, and you can finally see Bob is no longer in uniform motion. And the concept that we're going to talk about in this episode is speed. That's right. You may be wondering, 5 episodes of Kinematics, the physics of things in motion, and we haven't introduced speed yet? Well, this episode is all about speed. The reason I was hesitating to introduce speed earlier is because there could be some confusions between speed and velocity, but today you will understand exactly what speed is and what speed is not, and we'll be able to make a contrast between velocity and speed. So without any further ado, what is speed? We define speed as how quickly a particle moves. You may say, well, that is pretty similar to the definition of velocity which we had before. How quickly the position of a particle changes. Well, look at the difference. It's how quickly a particle moves and how quickly the position of a particle changes. Change of position and moving, aren't they the same things? Well, today we'll find out in this episode what exactly is the difference between them. Now, just like in velocity we have the two kinds, the average value and the instantaneous value, speed also comes in 2 flavors, the average one and the instantaneous one. So let me first go ahead and define the instantaneous speed mathematically. And the way we do that is pretty similar to how we define average velocity. So how did we define average velocity? Here it is. We defined it as a displacement, which is the change in position divided by the time taken. But now I no longer care about displacement, I care about moving. So we define the average speed as the distance traveled divided by the time it took to travel that distance. Okay? So this is the distance traveled, not displacement. Okay. The best way to understand the difference between average speed and average velocity is by doing an example. And here we have Bob, who's no longer going in uniform motion. So I'm just going to keep it over here. Let's try to understand what Bob is doing. Think about what's going on over here. Bob, at this particular position, that is time t equal to 0, is over here. Might not necessarily be at rest. We have not been given any information of his instantaneous velocity. We really don't know. Okay, but at t equal to 0, Bob is found at this position. And then we are given that at t equal to 2 seconds, Bob has come over here at x equal to 5. Turns instantly. We're going to assume that Bob doesn't waste any time at that particular point, so he just goes and zip, changes, and then he returns along the same path, and at time t equal to 8 seconds he's over here. So in the return part, the values of time I have denoted over here. And then finally at time t equal to 10 seconds he is at -1. And after that I really don't care what he's doing. Again, it doesn't mean that he has stopped here. It just means we stopped caring about Bob after 10 seconds. Okay. What kind of motion is this? Well, since no information is given, we have absolutely no clue whether he's going uniformly from here to here or whether it's stopping in between. We have no clue. So we have to assume that it's non-uniform motion without making any intrinsic assumptions. Okay, alright, so now the case is clear. Here are some questions we're gonna try and figure out. Okay? Alright, so the questions are, we want to figure out what the average speed and average velocity are at different intervals of time. Let's quickly try and figure this out. The first case is from 0 to 2 seconds. So 0 to 2 seconds, the time interval is 2 seconds. What is delta x? Well, I hope you remember delta x, which is the displacement, is defined as the final position minus the initial position. 0 to 2, so final position is 5. Initial position is 1. I hope you don't mind me doing this mentally. Okay, you want me to write it down? No, I'm not gonna write it down. Alright, so final position minus initial position, well, that's 4. And I better put my signs here, that's +4. Alright, what is the distance traveled? We're doing this calculation for the first time, but I'm pretty sure that's quite easy. What is the distance he traveled? How many meters he traveled? Well, he traveled 1, 2, 3, 4. So the distance traveled is also 4. Notice I don't put a plus sign over here because I don't really care whether it's traveling towards the right or traveling towards the left. Distance traveled is the number of steps that you take. And when you are calculating the number of steps, you don't care whether you're going towards the right or left. But displacement cares about that because it's the change in position. He cares about where you were before and where you are right now. So here it matters and here it doesn't matter. So what's the average velocity? Well, average velocity is delta x by delta t. Well, that's plus 2 meters per second. I'm going to use blue for that. So that's plus 2. Everything is SI units. I'm not mentioning the units. I don't want to clutter this thing. What is the average speed? Let me use, let's see. Let me use light blue for that. Average speed is going to be distance divided by the time taken. Distance is 4, time taken is 2, so that's also 2. Notice that this is in meters per second. So these units are having the same units. So in the first case, you get the same answer. Alright, let's go to second case. We want to calculate from 2 to 8 seconds. That's from here to here. 2 to 8 seconds. Alright, what is the time interval? That's easy. Time interval is 6 seconds. What is delta x? Let's see. Final position is 1. That's the final position. Initial position is 5. Let me just write that somewhere over here. So we have final position over here 1 minus initial position, which is 5. That's minus 4. Remember, final minus initial. So delta x is minus 4. Okay, what is distance traveled? Again, you calculate the number of steps he takes. He takes 1, 2, 3, 4. 4 steps, as in 4 meters. So the answer pretty much remains the same for distance. But again, I don't care about the sign. What's the average velocity? Let's see. The average velocity is delta x by delta t minus 4 by 6. What's minus 4 by 6? That's minus 2 by 3. Let me calculate. What's minus 2 by 3? That is point what? 3, 6, 18. It's 0.67. Okay. So the answer is going to be minus 0.67. I'm just going to call it minus 0.7. I hope you can see that. That's minus 0.7. Okay. What's the average speed? Well, average speed is also 4 by 6. So 4 by 6 is same as 2 by 3. 2 by 3, you get the same answer. 0.7. Alright. Notice now there's a difference. There is no sign here, but there's a negative sign. Okay. Next one. 0 to 8 seconds. What's the time interval? Well, that's 8 seconds. What is delta x? Delta x is 0. I hope you can see that. Because he has returned back to the same position. It's 1 minus 1, 0. What is the distance traveled from 0 to 8 seconds? Well, he first travels a distance of 4 meters towards the right. Then he again travels back 4 meters. So the distance traveled is 4 plus 4. It's 8 meters. So 8 divided by 8 gives me 1. So the speed turns out to be 1 here. But the average velocity turns out to be 0. You see that? That's the distinction that we have between average velocity and average speed. Average velocity can be 0, but average speed need not be 0. What's going on? Well, think of it this way. Suppose you were looking at Bob at t equal to 0. You look at him and you say, aha, Bob is at 1 meters. And then you close your eyes and you wait for 8 seconds. You open your eyes again and you say, aha, Bob is still there. So from your point of view, Bob has not changed his position. Well, Bob would argue saying that, I actually moved towards the right and then I came back. But you would say, well, I don't care whether you have moved or not, dude. Well, in the interval of 8 seconds, I don't see any change in your position. So as long as average velocity is concerned, you have not changed your position. That's why you get average velocity as 0. But what is the meaning of average speed here? Well, if you are concerned about average speed, it's how quickly he moved. that time you really don't care about his position. It doesn't matter whether he's come back to the same position or whether he has not come back. What matters is how much he moved divided by how much time he took to travel that distance. So if you wanted to know how much Bob moved, you really have to get your hands dirty, figure out exactly how much distance he traveled, and then divide it by the time. Calculating average velocity is easy. Think about it, even if I hadn't given you any information over here, you would still know that average velocity from 0 to 8 seconds is 0, because you don't care about how much motion he has had. All you care about is initial and the final position, and that's the same, and delta x is 0. If I did not give you this information and I asked you to calculate what the average speed is, you wouldn't be able to do that calculation, because you need to know whether he traveled 100 kilometers towards the right and then he came back, or whether he was not moving at all. So unless and until I give you the information of how much he has moved, you cannot calculate the average speed. I hope you understand now the clear-cut difference between average speed and average velocity. So calculating average speed is a little harder compared to calculating average velocity. Anyways, let's get this done from 0 to 10 seconds now. What's the time interval? That's 10. Okay, and how much is the displacement? Let's see. His final position is over here, that's -1. His initial position is +1. Let me do that here again. The final position at 10 seconds is -1. Final minus the initial position is 1. So that's -2. So he has a -2 displacement. What's the distance traveled? See, I told you, you have to figure out how much he moved. Did he directly go from here to here from 0 to 10 seconds? No. He went this way and then he came back. So we need to use that information. So he travels 4, an additional 4, and then he travels an additional 2. So he travels 10. Okay? So the distance he travels is 10 meters. This is 10. So what's the average velocity? Average velocity will be delta x by delta t, that's -0.2. I love to divide by 10. That's -0.2. So here is that, -0.2. And here, what's the average speed? Well, that's 10 by 10. I love that division as well. That's 1. Ta-da! We have calculated average speeds and average velocity. So what's the conclusion from this? What can you figure out? If I were to ask you to compare average speed and average velocity, what distinction do you see? Well, the first thing you see is that speed depends upon how much you move, but velocity depends upon how much his position has changed. Secondly, notice velocity has signs. You have to take care of sign. With speed, you don't need to take care of signs. Speed can only be calculated if I tell you the information of how much he has. If I hadn't given you this information that it turns instantly, you wouldn't be able to calculate the average speed because you don't know. Maybe he went forward and then he came back. You don't know. But since I gave you the information, you could calculate. You need all the information. Unless and until you do that, you don't know how to calculate speed, so it's harder to calculate. Alright, notice one more thing. If you look at the value of the speed, forget about the signs for now, just focus on the value. You will see in this case that both have same values, Speed is more than velocity, speed is still more than velocity. Can you think of a case where speed would be less than velocity? Think about it. Can we have average speed less than average velocity? Do you think that's possible? The answer is no. Because velocity, average velocity, depends on delta x, which is displacement, and speed depends on distance. And you may have read somewhere that displacement is also the shortest path between 2 points. You can't go shorter than that. Okay, so displacement will always be the shortest value of distance, and therefore you cannot beat displacement. And when I mean beat, you cannot go smaller than displacement. So distance traveled will always be bigger. Let me write that down over here. That's an important piece of information. Distance traveled will always be bigger or equal to, as you can see over here, compared to delta x. Therefore, what we will see is that speed, average speed, is always going to be bigger compared to average velocity. I hope this gives you a clear-cut distinction between average velocity and average speed. So what next? Instantaneous speed. Let's talk about that a little bit.